Fear not, Year 11, the revision saviour has arrived, and today we're going to be talking about meanders. Now, a meander is very simply a bend in the river. But before it's a bend, the river's channel would have looked rather more straight, and we need to understand how that meander develops from a straighter channel. Within the straight channel, we have areas of shallower water that are slow flowing, and these are called riffles. So they're slow flow and shallow. We have another one here. We also have areas of deeper water that is faster flowing, and these are called pools. So fast flow and deep. Now, the faster flowing water creates a line of fastest flow through the channel in this way. And this line of fastest flow is called the thalweg. Now, where that fastest flow comes into contact with the banks, it will start to erode those banks. So we see that happening here and here. So we can write erosion. But where the water is slow and shallow, because it has less energy, deposition will start to occur here, and we'll get some sediment and sand deposited in those slow flowing areas. The result is that we, in the end, are going to move towards these banks being eroded outwards in that direction, and this bank being built inwards in this direction, and this one inwards in this direction, and it will turn the straight river channel into the more commonly known or commonly seen bend of a meander. So in a second I'm going to ask you to pause your video, and you are going to try and redraw this diagram with the right labels, put into an annotated comment to show yourself what is happening. But just to get you on board, let's have a couple of questions. So, what is the name for the areas of slow flow and shallow water in a straight river channel? Correct, riffles. And what is the name for the areas of deeper flow, or deeper water and faster flow? Well done, that's pools. So where is erosion happening on this straight river channel? That's right, where the pools are close to the river bank. And why is erosion happening there? Because the thalweg comes into contact with it, and the higher energy is able to erode that bank. So where do we get deposition occurring? Excellent, where there are riffles and a slow flow. So take a moment now to pause the video, draw your own diagram, and then compare it to mine to see if you've missed anything out. Very good. Now let's move on. After some time, our straightened channel is now going to form the much more recognizable bend of a meander in the river. Now, in that meander, our fastest flow is going to move around in this way, coming into contact with some of the river banks, and so resulting in erosion. But before we go any further, let's try and name each side of the meander so that we can clearly talk about what is happening. So this narrowed, pinched part of the meander on this side we would call the inside bend. Whereas on this side, which is wide open, we will call that, surprise, surprise, the outside bend. Now, what's interesting to look at is the thalweg and where it is hitting the banks of the river. It is hitting the banks of the river on the outside bend of the meander. If you imagine this is another meander, this is also the outside bend here. So we are going to get erosion taking place here, and here, and here. Away from the thalweg, where the current is much slower, we are going to get some deposition occurring. So we will have deposition here, where the water is slow, there's low energy, and the material can no longer be transported. We would also expect to see some here and here on the inside bends of the meander. So outside bends, we have erosion, and inside bends we have deposition. And that is because there is high energy on the outside bend, and on the inside bend there is low energy with the slow flowing water. Slow flowing river. Jolly good. Let's have some quick questions. So, where would I be expecting erosion to occur on a meander? Very good. That's right, on the outside bend. And why would I expect deposition to be occurring on the inside bend? Well done. Yes, the energy is low because the river is flowing slowly, and so material is deposited. Excellent. So, once again, pause the video, try and draw for yourself from memory this stage of a meander formation, and then check it, compare it to mine, see how you've done. Let's move on to looking at the cross-section of a meander. So what I'm going to do is, from A to B, I'm going to cut the river in half and look at it from the side to see what's happening and show you the differences between the outside bend and the inside bend. So, the cross-section will look something like this. This is A, the outside bend, and this is B, the inside bend. Let's draw the water in, just to help you visualize what's going on. And we'll also put a little bit of vegetation up on the banks, some grass, and over here as well. Now we know that our fastest flow, our thalweg, is coming down the outside of the meander with high energy. In that fast flow, there will be material being carried or transported in suspension, fine silts and sands. That fine silt and sand being rubbed by the water against this bank here is going to cause erosion, and that type of erosion, where material is scouring or abrading a surface, is called abrasion. So abrasion is the specific type of erosion that is happening here. We can also say that because it's eroding sideways, we call this lateral erosion. Sideways, another word for that is lateral. Equally, on the bed of the river, we have some larger materials. like stones. And those larger materials are going to be transported by the process of traction, rolled along the bottom of the riverbed. And that rolling of material on the riverbed is going to result in erosion acting downwards. And the word that we use for downwards erosion is vertical erosion. So all of this erosive action that we have going on here, this lateral erosion and this vertical erosion, serves to make the river deeper on the outside bend, and it also creates this rather steep bank over here. The name for this steep bank is a river cliff. Now, on smaller rivers, river cliffs might be anything from 20 centimeters to half a meter, but on large rivers such as the Amazon or the Congo, river cliffs can be really quite large and be 10 or 20 meters high as the water erodes very rapidly. So, what's happening over here? Well, the key thing to note is that on the inside bend, the water is very shallow. And as a result of that shallow water, we have a lot of friction between the water and the bed and the bank. And that causes a slow flow and low energy. Those three things mean that the load that the river is transporting, all the sediment and stones, will be deposited, because it can no longer transport that material. I'm going to cross out transport, that is not happening, and instead we get deposition. So that material starts to build up on the slope of the inside bend as deposition. And you'll see that as a visible outcrop of sands and gravels. And this landform is called a slip-off slope, or sometimes a river beach. And these landforms on small rivers are just a couple of meters wide or so, but on large rivers they can really make a very large area of sand, so big that people hold markets on them, or where I lived in Kinshasa on the River Congo, people would go out to have parties on these beaches and enjoy themselves as you might a beach by the coast. They're that large. So this is the summary of what is happening here. And I'm going to ask you some questions about the meander. On which bend or which bank is erosion occurring? Good, the outside bend, well done. And what can you tell me about the type of erosion that's occurring to impress me with your knowledge of key words and processes? Very good. So it's abrasion by the load carried in suspension in the river, and that is causing the lateral erosion of the riverbank, the sideways erosion. But also on the bed we have traction, the process of traction, rolling material and causing the bed to get deeper through the process of vertical erosion. So explain to me what's happening on the inside bend. You might pause it now, explain it to yourself. Okay, so what's happening on the inside bend is that we have shallow water, and so there is a high friction which slows the flow, creating low energy so that the load is deposited to form a slip-off slope. So in this way, we can say that a meander bend is both an erosion and a deposition landform. Both processes are working on the meander, the erosion on the outside, the deposition on the inside. Now this diagram is really helpful for you to have a full understanding of how a meander works. So please pause your video and take time to try and recreate this diagram in your own, on your own, and instead of just writing keywords, annotate it with fully developed and explained sentences so that you have a clear understanding of what's going on at a meander bend. Once you've done it, unpause it and check it with my diagram. Okay, the last thing I want to share with you is that these meander bends are not static. They are constantly moving and changing their shape. So you can imagine that after some time, the erosion is going to cause the outside bank to move sideways. At the same time, the deposition and the formation of the slip-off slope is going to cause the inside bend to move in the same direction, also sideways. We can repeat that process, and it does, so that the outer bank moves even further to the left, more deposition occurs, and the inside bank, through deposition and the building of this slip-off slope, moves even further to the left as well. So over time, we can talk about the whole meander moving sideways, or more technically, we can call this meander migration. It will maintain its rough same shape, but its position on the floodplain will change as it migrates across the floodplain. Okay, well, there you have it. That is meanders in a nutshell. Now try writing yourself an answer to explain how meanders form and what processes are occurring on the inside bend and the outside bend. The only last thing left for me to say is to remind you that your case study for a meander is on the River Tees again. So we can talk about the River Tees. And there are many fine examples of meanders in the lower course on the floodplain. And you can talk specifically about the meanders south of the town of Darlington. And if you want to be super impressive, you can even name one. So have a look in your revision guide and find the name of a small town next to a very obvious meander and include that in your study. Best of luck, and I'll be back with another one soon. Bye bye.